This is the Math 1401 Zoom meeting for section 8.1. I think I will work some more problems from section 8.1. Hope everybody remembers from last week. It had two formulas in it. We called it Formula 1. There's really no work to do in Formula 1. In words, this means mean of the sampling distribution. I gave a little demonstration of how to create a sampling distribution. If you can take all possible samples, take the means of all the possible samples, and take the mean of the means, you wind up completing the circle and come right back to the population mean, which is how you can deduce the population mean by just sampling. And then the spread when you sample is reduced. Spread when you sample is reduced by the square root of the sample size. Okay, we'll just work through some problems in the homework, and maybe this will help you. Page 376. I think we did problem 9 last time. We'll try problem 11. This is again from 8.1. Oh, Miss Theophan, you've just joined us. I don't know if you want to see my first page or if you caught it. I was just trying to remind everybody what the formulas were in this section. We call them Formula 1 and Formula 2.
I just got here.
You show off.
Hello.
No problem. Did you have any questions or problems you wanted to see?
I would like to see some problem.
Well, I was going to just kind of work my way through the odd problems in the section here. I did number 9 last time, so let me start at problem 11.
Yes, that's good.
Okay. So in problem 11, they give you that the population mean is 52, population standard deviation of 10, sample size is 21, and they want you to find this and this. And so this directly uses Formula 1. Formula 1 back up. You actually are using a formula. It's just that there's nothing to do and they've given you the number, in effect, giving you the answer pretty much. And so following that formula, this is just 52. There's a little more work to do on this. They give you this and the n, and it's a matter of dividing by the square root of that n. So following that formula, I don't know if I keep them both on the screen, the standard deviation is 10 over the square root of 21. Usually keep a couple of places. Clear off. Divided by square root of 21. We'll call it 2.18. So the population had a standard deviation of 10. When we sampled it with sample size of 21, standard deviation got reduced to 2.18. This again of the sampling distribution, because when you sample and take the centers or means of the samples, it's a much narrower distribution than the original numbers. And just an exercise in using these two formulas. Number 2, by the way, is much more important than number 1. We're only going to use number 1 in this section. We will use number 2. This will correct standard deviation or sample size. We'll show you where that comes up later in the section. Is there anything you want to ask?
No, I understand this so far.
Okay. Oh, we have another participant, but I don't have your name on the screen. Would that be Miss Obeys?
Yes, please.
Ah, okay.
Good evening, sir.
Okay. Do you have any questions or problems you want to see worked?
No, please. I don't have any question.
Well, I'm just kind of working through the odd problems here. Is that all right?
Yes, please.
Okay. I don't know if you just joined us, but remind you that this section is about these 2 formulas. This one, there's not a lot of work to do. There's not any work to do, actually. And this one, you wind up dividing by the square root of the sample size. So a little more work, but not outrageous. Now, when you go to 13, there's a bunch of parts. In fact, maybe I'll go ahead and start on the top of a clean sheet of paper, trying to get most of it on one sheet. So we don't have to flip among sheets. 13 gives you a bell curve. It tells you 500, and that's actually going to be this. And the reason I know that, and then over this side, they give you a 480, and over this side, they give you a 520. The reason I know that is if you read the paragraph, this is why it's important to know about the words. This is a sampling distribution of the sample mean. So this is not a population. So this is not this. Okay. So then in part A, when it asks what is value of mean X bar here, well, the answer is 500. You can see it. What is the value of that mean X bar? It's almost just giving it to you, the 500 in the center. So B, what is the value of the sigma X bar? Well, that's just going to be the difference. You can either do it 520 minus 500 or 500 minus 480, but the difference up here is 20. Sigma X bar is going to be 20. The X bar here is your 500. All right, C asks if the sample size is 16, what's
So
like?
in this one, I have a question, Mr.
Yes,
C.
go ahead.
In this one, you couldn't do 520 minus 480
No,
for
that
standard
would-
deviation to get.
your standard deviation, remember, is average distance from the mean, which is in the
Okay.
center. Yeah. So if you do here to here, you're actually double what it is.
Okay, thank you.
But you do have your choice of 500 minus 480 or the 520 minus 500.
Okay, thanks. I
So on
see.
the example, it was 500 minus 520.
Yeah, but remember it's positive. So you want to go larger minus smaller.
520 minus 500. Yeah.
Right. Or the 500 minus 480.
Okay.
You can use either one.
So you can use either the front or the back.
That's correct.
Okay, thank you.
All right, C asks what the shape is, or what is likely true about the shape, and it would be normal. You can, kind of see they've given you a normal curve, and that's all we work with. And D. Now, D is a little tricky. Your sample size is 16. What is the standard deviation of the population? That's what's really clear. what is the standard deviation of the population? In other words, population standard deviation. I'll abbreviate it this way, find this. Well, if you look at Formula 2, it was read this. So this is what we're trying to find. So you can see if we multiply by the square root of n and the square root of n, I have to go to a second page, I guess. This is going to cancel. I'll leave this up on the screen. This is going to be equal to, I'll reverse the order, the sigma x bar times the square root of n. I'll reverse the order here because this is not under the root. So plugging and chugging, this was 20 times the square root of 16. N is 16. So that's under the root. And then this worked out 20 from up here. So in effect, you have 20 times 4, which is 80. The original population had a standard deviation of 80. Okay, questions about that? A bunch of little parts to that one.
No, thank you.
Okay. Well, why don't we, sorry, go ahead. Did you have
No,
something?
I said no, no question.
No, okay. Well, why don't we jump ahead to, say problem like 19 again. Now, I did do this last time, but maybe I should repeat it just to make the, and there's a bunch of parts. We can work our way down through them. All right, now they're flat out giving me that a mean is 266 and a standard deviation is 16. So this is talking about the length of human pregnancies. It's saying they last an average of 266 days. Usually we think of it as 9 months, you know, usually kind of, and aren't you so glad you now know that the standard deviation is 16? Okay. A, what is the probability a randomly selected pregnancy lasts less than 260? Part A, I'm repeating this just to make the point. I don't know if y'all actually watched the first video or not, or you may have been there actually. I don't know if you, it's been about a week. And exactly a week. It was last Monday, wasn't it? Yeah, that's right.
Yes, we were here, I think.
I don't know if y'all remember any of this.
I don't remember this.
Okay. So no problem. We'll repeat it. So they want the probability that pick a random pregnancy and it'll last less than 260 days. All right. Notice through all this paragraph, through the question they've asked, have you heard any mention of a sample size?
No.
No, which means this is out of section 7.2. So far, no n value given. So this works exactly like section 7.2. Your z value is going to be 260 minus 266 divided by the square root of 16.
Oh, 16. Mhm.
X minus your mean divided by, I'm sorry, my fault, getting this confused late, divided by the standard deviation. I'll rewrite it. 260 minus 266 divided by straight 16.
Mhm.
X minus, it's your z-score formula, X minus mean divided by standard deviation. So if I punch that,
6 and 16.
260 minus 266, I got to turn the calculator on, my fault. 260 minus 266 divided by 16. There you are. Negative 0.375. We'll probably just call it negative 0.38 because you only can use 2 places on the table. But use 3.7, that's perfectly fine. I have my tables, doggone negligence. I should have grabbed them. I got them here somewhere. Y'all got your tables? Amazing how they can, I had them here. I'm gone, I had them here. Have y'all got your tables?
Yes, please.
Ah, okay, found them. All right, so I don't know if you've looked it up. Negative 0.38, negative 0.3. 08 column 3520. Put that on the screen. 3520. Table. Probability is 0.3520, and that will be the direct percentage or probability. It's our answer. It's a direct table lookup. Okay, questions about that?
No, please.
Okay, so notice how they have mixed in chapter 7 problems here, even though we're in chapter 8. All right, so B, we're going to kind of skip. C, now they tell us we have a sample of 20. Then they ask the same question. Find the probability that you're less than 260. Okay, this is going to picture the same way. 266, 260. Standard deviation is 16. But here's the difference. When this, we're going to use formula 2.
So is it going to be 266 minus 260?
No, you got it backwards. It's
Oh, you're going
260
260 minus 266 all over 20.
See, since now we're sampling, the standard deviation changes to this.
Okay.
Which is the original standard deviation divided by the square root of the sample size.
Okay.
Which is going to be 16 divided by the square root of 20. That's the only change when they give you a sample size. You've got to make this adjustment. See, in part A, it's a straight 16. No sampling number was given.
Okay.
But in part B, with a sample of 20, that 16 is divided by the square root of that sample size.
Okay.
I'm gonna write, I like to do it all at once. You could do this and get a separate number and then divide it. That works. I'm gonna do it all at once. So I'm gonna punch it this way. 260 minus the 266 divided by another parentheses, 16 divided by the square root. I think the calculator has parentheses around that 20. So it looks a little tough, but it really isn't once you get used to it. I could call it back and just use the throw, but I'll just punch it from scratch. 260 minus 266, close, divided by another parentheses, 16 divided by the square root of 20, close, close. You pause. I think everything is matched. Hit enter, and the standard deviation changes to 1.67, negative 1.677.
Negative 1.68.
We'll call it negative 1.68. And now you look that up. Negative 1.6, all the way over to the 08 column. And you get 0.0465.
0.0465, yeah.
Okay. It's the same identical question, but the differences are, this is talking about a single pregnancy. 35% chance it'll be premature. If you want to call 260 or less premature, early. The second question asks the same question, but the difference is they want to know about the mean of a sample of 20. And you see it's a lot lower chance that a mean of a sample of 20 will be less than 260 days. See how much lower a chance of that happening is than a single pregnancy. So that's the difference in the problems. Questions about that?
No, please.
All right, well, there's a lot of parts left. What they do is start changing the sample size. They keep the same question here. They just increase the sample size. So part D goes to see, it's 260 or less, if you can read that. It's 260 to part D. 260 or less, but it's a sample of 50. Part E, what might you conclude a sample fit resulted in? Okay, and what is the probability of, okay, now I change it to size 15 and within 10 days. Do you want to see any of those parts, or do you want me to switch the numbers and switch the problem? Like 21's about reading rates. 23 is about rates of return in stocks. The number's a little nastier in 23. Rates of return in stocks. And I think that's where we changed them or stopped. What do y'all prefer? Keep going with the pregnancies or switch to one of these others just to use different numbers?
I think with the pregnancy, so that we continue with the same figure so that we can better understand. I think I can better understand.
Okay, so continue down with the pregnancies?
Yes, please.
All right, so we'll go to D. So this is page 376, 19, part D. Now the sample size is 50. Find the probability you're less than 260. We almost can use the editing on the calculator once you see how the numbers work. 266, 260. Now the sample size is 50. When you do your Z number, you're going to get your 266. That's two. I got it backwards. My fault. Okay, I'm sorry. This is correct. This should be the 260 minus
266.
Right, my fault. Yeah, your X minus your mean divided by your 16.
16.
But that's divided by the square root of 50.
Mm-hmm.
The calculator will have little parentheses around the 50. You can almost call it back. Second enter. And change the 20 to a 50. I got juice, change that one too. Oh, went too far. Make that a 50. And I'm at negative 2.65 standard deviations. You see how the number of the standard deviations increases, even though these numbers are the same. When you increase that in, your number of standard deviations that this is away from this changes. And it gets further away in standard deviations. Split off the 5.
0.0040.
0.0040, negative
Yes, please.
2.6. 65. Yep, negative 0.0040.
Yes, please.
That's 0.4%. That's really small that a mean of a sample of 50 would come out 260 or less. Well, the chance is starting to get really, really small. Are you ready for the next one?
Yes, please.
Okay. What might you conclude? A random sample of 50 resulted in a... That's worded very badly. I assume that they're going for the case that this is less than 0.05. Your probability from D being 0.004 is less than 0.05. So you can conclude it's unusual.
It's unusual.
That's what I would assume he's going for. Now in F, he changes the sample size to 15, and you want a probability within 10 days of the mean. So if you picture that, 266 at the center. If you're within 10 days high, you could be, that'd be a 276. Or within 10 days low would be 256. So if you're between 256 and 276, you're within 10 days of the mean. So we're going to need Z numbers for both of those. So call this number 1 and this number 2. So for number 1, your Z number is going to be 256 minus 266 divided by your 16 divided by the square root of 15. Is this going too fast? Remember, your standard deviation was 16.
No, please.
No.
I'll write out the other one, then we'll punch them both. What if we punch this one? We could just tweak a few numbers. Probably only have to tweak that 5 there and make it a 7. But I'll write it out and show you. 276 minus 266 divided by 16 divided by the square root of 15. So yeah, the only difference in these two is, well, of course, this will be negative, this positive, but the only other difference is the 5 changes to a 7. You punch either one first and then change it to the other one. So I'll do the first one. 256 minus 266 divided by parentheses 16 divided by the square root of 15. It's matched. Negative 2.42.
Okay.
All right. You see, all I got to do is call it back. Run the cursor up and over and make that a, ooh, I went one too far. 7, make that a 7.
Yeah, the same answer, but positive.
Positive, yep. Yeah, that's because they're equidistant.
Yes, please.
Yeah. So that's positive 2.42. Want to shade in between.
So the first one will be 0.0078.
0.0078.
Yes, please.
Okay. Remember, that's
Then
left.
the second one will be 0.9922.
Ooh, and I missed the last digit.
2.
22?
Yes, please. 0.9922.
0.9922. Okay. So you remember what to do with both of these?
Yes, you take 0.9922 minus 0.0078. I think so.
That's right. You got it. There's no new tricks.
Okay.
9922 minus 0.0078. 9844. Yeah, 98% of pregnancies are within 10 days of that mean. So, you know, if you got one lasted longer, that baby really don't want to come. And if you got one shorter, then you've got a preemie. All right, well, that's all the parts of that one. Have y'all had all you can stand, or do you want to see some examples of some of the others? Or think you can figure out some of the others, haven't seen this one.
Okay.
We'll give one more session on Thursday
Okay.
at 12 and noon.
On 8.1 again, or
Yes,
it would
yes.
be new?
No, it'd be 8.1. With only 3 days last week, there wasn't time to, do anything else other than 8.1 with just one session. And then, this week we'll just, you had your spring break, and I hope you enjoyed it. And we'll just do 8.1 this week. So the session on Thursday will also be on 8.1. We can work more of the problems through if you want to see them.
Okay. Thank you so much.
I think it's gonna get us started.
Hopefully it will. Yeah.
Yeah.
All right. Well, see you on Thursday then. That enough for tonight?
All right. Thank you, sir.
Sure thing.
Thank you. Have
Appreciate
a
y'all
wonderful
coming
day.
out. Thank you.